Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mushtaq Muhammad. I usually teach mathematics at secondary level. We know the conditions outside are not favorable for the students to have tuitions. Schools are closed, everything is closed. So better is to stay inside, stay safe. I have decided to deliver some topics from class 10th mathematics so that students in general may get benefited. If you find anything difficult in my topics, anything that is inconvenient, I will be pleased to hear your suggestions, your comments on the comment box. This lecture will be available on YouTube and it will also be available on the Facebook. Today I have chosen a topic from class 10th math, that is quadratic equation. I will try to deliver this topic in a more convenient way because it has rightly been said that mathematics in its best way is a logical poetry, and it is a logical poetry. So starting our lecture, starting our topic, that is quadratic equations, we must know what actually equation mean. What actually equation mean, it is necessary to know how equations are formed and what makes the basis of the equation, that needs to be understood. So let's start from the basics. You might have heard these terms. There are various terms, like we say variables and constants. Let's talk of these two terms, what variables are and what constants are. It is a quantity which is liable to change, and constants, you know, always remain constant. It remains static, it does not change its state. These variables are liable to change, and usually these variables are denoted by small English alphabet, small letters like X, T, Z, Y, U, V. It is a notation. These are generally denoted by these things. And when we join variables and constants, when we join them by means of four basic mathematical operations, that is addition, subtraction, multiplication and division. When we join variables and constants by means of four basic mathematical operations, that is with addition, subtraction, multiplication and division, expressions are formed. Like if we join variable x by a mathematical operation addition to some constant 5, so we get an expression x plus 5. It means x is a quantity to which 5 is added. Although this x is a hidden quantity, but we say it expresses something. That means x is a quantity to which 5 is added. Like this, I would like this. It is 2x square plus 9. So 2x square is a term with variable x and 9 is added to this. It is an expression. All these expressions are called algebraic expressions. Now, on the basis of number of terms, this x is a term, this 5 is a term, this 2x square is a term, this 9 is a term. Now, on the basis of terms, we name the algebraic expressions differently. For example, if an algebraic expression is having a single term, suppose it is 2x power 3, it is a single term. single term because it is not involved to some another term by means of an operation, addition, subtraction. This 2 is a coefficient of the term and this 3 is a power of the variable. 6, 9, 100, x power 100, these are single terms. These single term algebraic expressions are called monomials. Now, if there are two terms joined by a mathematical operation like this x plus 5, it has two terms, 1 and 2, then it is a binomial. Now, if it is like this 2x square plus 5x plus 9, now it has three terms, 1, 2 and 3. This algebraic expression is called a trinomial or simply a polynomial. Hence, a polynomial is an algebraic expression having more than two terms. So, let us see. Now, when we equate an algebraic expression with a constant, when we equate, for example, 5x plus 3x is equal to 9. 5x square plus 3x plus is equal to, it means we are equating this algebraic expression with a constant, it forms an equation. Now this equation has two parts, one is LHS and one is RHS. Now how we define equation then? An algebraic expression, when we equate an algebraic expression with some constant, an equation is formed. Now it actually means it is a condition on the variable. This equation means it is a condition on the variable. Variable is x such that LHS always becomes RHS. So that means what value we must give to this x so that this LHS should be equal to RHS. This is called the definition of the equation. And equation is usually defined by, it is a condition on the variable such that LHS is always equal to RHS. It is the definition of the algebraic equation. So, when we started with terms, variables and constants. Variable is a quantity that is liable to change and constants are always constant. They do not change their state. When we join variables and constants by means of four basic operations, that is addition, subtraction, multiplication and division, algebraic expressions are formed. Now on the basis of number of terms, an algebraic expression is named as monomial if it had a single term, binomial if it has two terms, trinomial if it has three terms, and polynomial means an algebraic expression having more than two terms. When we equate an algebraic expression with some constant, an equation is formed. Now the equation states that it is a condition on the variable such that LHS is always equal to RHS. Now, in order to get differences, in order to differentiate a trinomial, a binomial, a biquadratic equation, a triquadratic equation, a cubic equation, an equation of the form ax square plus bx plus c is equal to 0 is called a quadratic equation. This equation is said to be a quadratic equation. Now what actually quadrate means? It is quad. Quad means square. Quad means square. The term quad, it was first used by John Milkins. He was an English writer in 1668. He used this term quad in his essay. First it was used then. It was simply denoted to differentiate various types of equations. Simply. Otherwise, it has no proper definition. It has simply been placed there to get differentiate between various types of equations, like a linear equation, cubic equation, fourth power equation, fifth power equation. So it is named as a quadratic equation. Quadratic means an equation of the form x square plus bx plus c is equal to 0. It means any equation which has degree 2. Any sort of equation which has degree 2, Degree means it is the highest power of the variable when the terms are placed in the descending order. That means descending means here the power of the variable is 2 Then second term is a is a term with degree 1 and c is a constant. So these terms are placed in the descending order 2, 1 and 0. So it means it is the highest degree is 2, so it is a quadratic equation. Any equation with degree 2 is said to be a quadratic equation. But the condition here is a should not be equal to 0. A should not be equal to 0. Now suppose a is equal to 0. If a is equal to 0, this ax square becomes 0 into x square, that is 0. So this term vanishes. Here remains bx plus c. Now the degree of the variable is 1, so it becomes a linear equation. It becomes a linear equation. So the condition is that a should not be equal to 0, where also a comma b comma c are real numbers. Real number means a number that can be placed on the number line. Number line means it is a collection of various points like natural numbers, whole numbers, real numbers, rational numbers, irrational numbers, decimals, fractions. All those numbers, they are called real numbers. So, and one thing is a should not be equal to 0. So quadratic equation is an equation of the form ax square plus bx plus c is equal to 0. It means an algebraic expression with degree 2 is said to be a quadratic equation if it is of the form ax square plus bx plus c is equal to 0. This equation was placed by Brahmagupta. He placed ax square plus bx plus c is equal to c. This was an explicit formula produced by Brahmagupta. Now actually what is the fun behind placing quadratic equations in 10th class exam, 10th class syllabus? There is a wider scope of quadratic equations in various fields. Various problems that we face in our day-to-day life are solved by the means of quadratic equations. Quoting various examples, let's quote the example of a 6, where batsman hits a 6. In order to get the different distance traveled by the 6, like this, from this pitch, the ball goes to the stands. Now, in order to get the distance traveled by the ball from the pitch to the stadium, to the audience or something where the ball hits after striking the bat, there is formed a curve. And in order to get the distance traveled by the ball, we need to understand the quadratic equation of the curve. Yes, simply a fountain is playing. In order to get the path of these fountains, we need to know the path, we need to know the curve. Let's take an example how a quadratic equation is formed. Let us suppose we are having a field like this, a rectangular field of area 120 meters square, and it is said that the breadth of the rectangular field is twice its length. Area of field is given 120 meters square, and we are also stated that the length of the rectangular field is 1 more than its breadth. Now here you can observe that neither length is given, neither breadth is given. We are just stated that length is 1 more than twice breadth. Let us suppose that it has breadth 2x, and what becomes the length? It is 1 more than twice the breadth. Now, how can we construct a quadratic equation? Simply, area of rectangular field is always equal to length into breadth. Now, length into breadth is equal to area. Area is 120 meters square. So it is 2x into x is 2x square plus x is equal to 120 meters square. Simply we can write this like it is 2x square plus x minus 120 is equal to 0. So it has degree 2, that means it is a quadratic equation. Now we need to find the dimensions of the field. For that we have to find the roots of the quadratic equation. That means we have to find the value of the variable in the quadratic equation. For that we need to know the roots of the quadratic equation. So what actually a root of a quadratic equation is? It is simply the value of the variable that satisfies a given quadratic equation. We say alpha is the root of ax square plus bx plus c is equal to 0 if a alpha square plus b alpha plus c is equal to 0. It means this alpha is the 0 of the quadratic equation ax square plus bx plus c. That means it satisfies the quadratic equation. It creates a balance between LHS and RHS. So this alpha is said to be the root of the quadratic equation. In order to find the root of the quadratic equation, there are various procedures. Here we are going to learn first procedure, that is factorization or splitting the middle term. Factorization or splitting the middle term. Now let us see how we can factorize a quadratic equation in order to get the root of the quadratic equation. Now let's take an example of a quadratic equation x square plus 5x plus 6 is equal to 0. We consider this quadratic equation. X square plus 5x plus 6 is equal to 0. How we are going to factorize the equation? Let us first visualize what actually this quadratic equation means. So let's take an xy plane like this. Taking this first term, it is x square. That means it is a square term. It is a square term with dimension x. So we are going to construct a square like this. Of dimension is x. It is a square. Now what is this 5x? This is a rectangle of length x and width 5. So we are going like this. It is 1. I will make this like this. This is x. 1, 2, 3, 4, 5. I am going to split it into 5 parts. Each part of dimension 1 by x. So it is 1 by x, 1 by x, 1 by x, 1 by x, 1. These are the 5 parts of this equation. Now actually what 6 is? This 6 is also a rectangle. 3, 4, 5. 1, 2, 3, 4, 5 and 6. It is 6 by 1. Now I'm going to split this 6 in 2 factors, into 2 numbers. But the sum of that 2 numbers should be equal to the coefficient of the middle term. That means I have to split 2 into 2 numbers. If I find the sum of the 2 numbers, that should be equal to 5. So I am going to choose 3 by 2. 3 by 2. I make from this a 3 by 2 rectangle. 1, 2 and 3. So this is 3 by 2. This is 3 by 2. Now what I am going to do is there. Again here. This is xy plane. This is x. 1 and 2. This is 3 and this is 2. So I splitted this 5 into 2 numbers, that is 3 and 2. 3 into 2 is 6 and 3 plus 2 is 5. I'm dragging these 3 to downwards. These 3 like this. 1, 2 and 3. So it is x and it is 1 plus 2 plus 1, that is 3. So it becomes x plus 3. What remains here? It is x and plus 2, that is x plus 2 up to this side. Now what remains here? I have to make a complete rectangle from this in order to find the area of the rectangle. So what I place it here, it is 6, that is 3 by 2. That is 3 by 2. Now I am going to place this 3 by 2 here. So this is like this. Now it becomes a complete rectangle. It becomes a complete rectangle with x plus 3 and x plus 2 as dimensions. Now, in order to get the area of the rectangle filled, we need to multiply the length by width. So we are going to this. It is x plus 3 into x plus 2 is equal to 0. this whole becomes the area, that is x square plus 5x plus c is equal to 0. Now this whole equation becomes the area of the rectangle. So I have split it into two factors, length into breadth. So length is x plus 3 and width is x plus 2 is equal to 0. Now either this is equal to 0 or this is equal to 0. When x plus 3 is equal to 0, x becomes minus 3. When x plus 2 is equal to 0, x becomes minus 2. X becomes minus 2. So I have found here two roots of the quadratic equation, x square plus 5x plus c, that is x is equal to minus 3, x is equal to minus 2. Now let us check whether our results are correct or not. If x is equal to minus 3, it is x square plus 5x plus 6 is equal to 0. It becomes, in place of x, we have to take minus 3 ka square plus minus 3 plus 6 is equal to 0. It is 3 3s are 9 minus 15 plus 6 is equal to 0. This implies 9 plus 6 is 15 minus 15 is equal to 0, which implies 0 is equal to 0. So LHS is equal to RHS. It means the equation is satisfied by x is equal to minus 3. Similarly, we can see x minus 2 is a root of the quadratic equation. Now I will add one more thing here. Just check it out. This is x plus 3 is equal to 0. How it becomes x is equal to minus 3? I have heard many of the students, they say that we are transposing this 3 to RHS. Actually, what procedure, how we are making this x is equal to minus 3, we are not transposing this quantity to this. What we are doing, we are adding the same quantity on both sides. In order to get this 3 eliminated, if I have to eliminate a quantity, what I need to do, we add the inverse of the same. We add the inverse of the same quantity to the quantity. For example, if I have to eliminate 3, what I need to do, I have to add the inverse of this number, that is 3 minus 3 is equal to 0. So actually what we are doing here, it is x plus 3 minus 3 is equal to 0 minus 3. We are adding the same quantity on both sides. So from this side 3 and 3 goes, and from this side it remains. So x is equal to minus 3. So it is the procedure. Now we have visualized what actually a quadratic equation means. It was a square. I made a square, then I splitted this rectangular field into 5 small components, and this 6 into 3 by 2 components, because 3 by 2 is 6 and the sum of the two numbers is equal to the quotient of this middle term. Then I constructed a whole square. I get the length and width of the rectangular field. In order to get the area of the, because this quadratic equation is actually the area of the field. So area is always obtained by length into breadth of the rectangular field. Thereby I